let's look at this problem right here. This question is asking, in a diffraction grating experiment, light of 569 nanometer wavelength produces a first order maximum 0.34 millimeter from the central maximum on a distant screen. A second monochromatic source produces a third order maximum 0.86 millimeter from the central maximum when it passes through the same diffraction grating. What is the wavelength of the light from the second source? Okay, here the question is asking to find out the wavelength from the second source. Okay, here we are going to use this equation, n lambda is equal to dx over L, and you can also write this one as n lambda d times x over L, because this x over L value, it's not provided. So that's what we are going to solve for. We are going to use the first situation to solve for x over L. Then we are going to use the same equation again to find out the lambda, right? First lambda is provided, that is 569. But before I do that, okay, let's rearrange this one in terms of x and L, because x over L is going to be equivalent to n lambda over d, and n is, since this is a first order, the first situation, that's the first order, so n is going to be 1, and lambda is the wavelength, that is 569 times 10 to the power of minus 9, and then we have the d, that is the distance from the central maximum, that is 0.34 times 10 to the power of minus 3, and if you calculate this one, you're going to get 0.00167, right? So this is our x over L value. Actually, there's no unit, x over L value. And then we are going to plug this one in the second situation. Let's go to the second situation. In the second situation, we are going to use the same equation, n lambda is equal to d times x over L. Here our purpose is to find out the wavelength in the second condition. Okay, in the second source, the wavelength is going to be equal to d over n and then multiply by x over L, and the d is the distance from the central maximum, that is given by 0.86 millimeter, that's going to be 10 to the power minus 3, and then x over L we calculated, that is 0.00167, and then we are going to put this n value. The second one is third order, it mentioned right here, it's a third order, right? So second source is third order, we put 3 right here because n is the order, so that's 3, and if you calculate this one, you're going to get 478.733 times 10 to the power of minus 9. So this is in meter, and in nanometer that's going to be 470. If we want to round this one into 3 significant figures, this is going to be just 479 nanometer, and that's going to be our final answer. I hope this helps. Thanks for watching.